So that's beginning, and then I'll come back and share this screen again. So again, this Zoom meeting is being recorded. It'll appear in my Zoom, on my YouTube channel, Math with Mayo, later on. If you don't want to be seen or heard, leave your video off and change your name or whatever. But and if you have questions, you can ask them during this video, but if you want to wait, you can email me and I'll answer them later. All right, so any questions about that before we go on? Okay, so today we're going to be covering section 6.1, which has to do with finding the greatest common factor. Chapter 6 is all about factoring. It's a building process. So we're going to begin at the beginning and we'll keep adding little pieces to the process. So first of all, we're going to look at just finding the greatest common factor of a couple of integers. So let's say we've got 10 and 15, all right? So we're looking for the greatest common factor. Now, numbers are small. Hopefully it's easy enough. You can look at it and figure it out, but I want to talk about the process. If we take each of these numbers and break them down into prime factoring, 10 would be 2 times 5, and 15 would be 3 times 5. So the greatest common factor, well, what's the largest factor that they both have in common? That would be the 5. So the greatest common factor of 10 and 5, excuse me, of 10 and 15 is 5. Any questions about that? All right. Let's take a look at another one. 16, 24, and 48. Well, if we break 16 down into prime factors, let's see, 4 times 4, 2 times 2 times 2 times 2. So there's 4 factors of 2. 24 would be what? 2 times 12, 2 times 2 times 6, 2 times 2 times 2 times 3. 48 is, let's see, 6 times 8, 2 times 3 times 2 times 2 times 2, or 2 times 2 times 2 times 2 times 3. Okay. Typically, when we do prime factorization, we put them in increasing or ascending order. All right, I can see that they all have a 2 in common. So 2 is a common factor, but it's not the greatest common factor. They also share a second 2. In fact, they share a third 2. That's all though. They don't share another 2 or a 3. So the greatest common factor would be 2 times 2 times 2, or 8. So 8 is the largest number that's a factor of 16, 24, and 48. Any questions on that? Good to go. All right. Let's say we've got c squared and c to the 7th power. Well, we could break these down and write this as c times c, and this is c times c times c times c. That's a lot of c's. 7 c's, right? It's like sailing on the 7 seas. Okay, and we see that there are 2 c's, so the greatest common factor is c squared. Well, we could have saved ourselves a lot of trouble by just looking at this and saying, well, which one is the lowest power of c? This one. So that's common to both of them. All right. Okay. Let's see here. Let's say we've got 9a and 21. So 9a would be 3 times 3 times a, and 21 would be 3 times 7. So the greatest common factor is what? Just plain old 3. We all right with this? Any questions there? Good to go? All right. Let's say we've got 33 m to the 5th power, 22 m to the 6th power, 11 m to the 5th power. Let's separate these into the coefficients and the variables, the coefficients being the numbers. So 33 is what? 3 times 11. 22 is 2 times 11, and 11 is 11. So numerically, 11 would be common to both, or to all three of them. But what power of m is common to all of them? It would be m to the 5th power. All right? So greatest common factor, 11, m to the 5th power. Questions there? We good? Rebecca? Okay. All right. Let's see here. How about this one? 2 times the quantity y minus 1 and 5 times the quantity y minus 1. So the first term is a product of 2 and y minus 1. The second term is a product of 5 and y minus 1. So what's the greatest common factor of both of these? It would be y minus 1, because it is a factor over here and a factor over there. Now, when I write it here, I need parentheses around it because it's being multiplied by the 5 or the 2, but writing it here, I don't need that because it's just that quantity. You could put it there, but you don't need them either way. Okay. Let's see here. 18x plus 24. Now, the directions change here. The first problem, I guess I should have emphasized this. The first one said, find the greatest common factor of each list of terms. So we identified it. Now it says, factor out the greatest common factor. So here, the greatest common factor, can you see what it is? Can you see that it's a 6? All right, but I'm not going to just write 6. I'm going to write 6 times what's left over, 3x plus 4, okay? Because I've got to get 18x plus 24 if I go back the other direction. So we're taking out the greatest common factor, but also showing what's left over. So we should have a product that when we multiply it back together, it takes us back to where we started from. Let's see here. B to the 4th minus b to the 3rd minus 3b squared. Factor out the greatest common factor. That would be b squared. So b squared times b squared would be b to the 4th. B squared times minus b would be minus b to the 3rd. And b squared times minus 3 would be minus 3b squared. So there's your final answer. We good to go? All right. How about this one? Let's see. 3x squared y cubed minus 9x to the 4th y cubed. So again, it says take out or factor out the greatest common factor. So looking at the coefficients of 3 and 9, I could take out a 3. Looking at the x squared and the x to the 4th, I could take out x squared. And looking at y cubed and y cubed, I can take out y cubed. So then I've got to have this. Now, be careful. A common mistake that people make is they say, well, I've already got this right here, but you've got to have a 1 there because you've got to be able to get back here by distributing. So I need a 1 and then minus 3x squared, so that when I multiply it back out, I get 3x squared y cubed minus 9x to the 4th y cubed. So this is our answer right there, and checking it would be multiplying it back to there. Good to go on that? All right. Here the directions say factor out a -1. So we're going to rewrite this as -1 times whatever's left. So -1 times x would be -1x. -1 times a positive 2y would be a -2y. So factoring out a -1 changes the sign of each term that'll be left inside the parentheses. Good to go there? Okay. All right, let's see here. Now, let's say we've got y times the quantity x plus 2 plus 3 times the quantity x plus 2. And the directions say factor. So what is the greatest common factor? We've got y and x plus 2, 3 and x plus 2. So it looks like x plus 2 is the common factor. So we're going to take that out, but what's left over? Y plus 3. So this was the takeout and this was the leftover, so to speak. All righty, let's do that again. I've got m times the quantity p minus q minus 5 times the quantity p minus q. So here, the greatest common factor is p minus q, and the leftovers are m minus 5. Any questions about how that's working? Okay. Let's take a look at this one. bx plus bz plus 5x plus 5z. So there are 4 terms in this expression. But if I look at all 4 terms, the only thing that's common to all 4 of them is just the number 1. So I could write 1 times the whole thing, but that doesn't really do much for me in this context. What I'm going to do, the directions actually say factor by grouping. We're going to cut this into groups, 2 groups of 2 terms. Okay? So now let's take a look at this first group. The greatest common factor there is a b with the leftovers of x plus z. Let's take a look at the second group. The greatest common factor there is a 5 with the leftovers of x plus z. But I need to put a sign right in here, which would be a plus sign to get plus 5x plus 5z. Okay. Let's see here if I can, oops, I can never get this eraser to work. There we go. Okay. So now it looks like some of the previous problems. The greatest common factor is an x plus z, and the leftovers is b plus 5. So we take these 4 terms and write them as a single product. So we've factored it completely. So this is what's referred to as factoring by grouping. Typically, if there's 4 terms, we group it into 2 groups of 2 and go from there. Any questions on that example? Nope. All right. 12ab minus 4ac plus 3db minus dc. So once again, we have 4 terms. And if you look across all 4 terms, there's nothing common to all of them except a 1. So we'll split it into 2 groups of 2. If at any point I'm going too fast and you need me to slow down, please let me know. Or if you're falling asleep because I'm going too slow, let me know and I'll speed up. Whatever, I'm here for you. Okay, nice smile there. All right, so the greatest common factor of the first two terms would be 4a. The leftovers would be 3b minus c. In the second group, the greatest common factor is d, and the leftovers are 3b minus c. What do I need between these two? What sign? Do I need a plus sign or a minus sign right in here? It would be a plus sign, wouldn't it? Okay. Notice these two match. So if we take out 3b minus c, we have 4a plus d, and we're done. Now, you might be thinking, it seems like an interesting coincidence that these always seem to match. These problems are set up this way, so they are going to match. But the context that we're going to be using this idea, they will match. So it's not like you could just randomly pick some expressions and write them down and this would happen. Okay. It's being set up this way. Okay, let's see here. How about this one? Yeah, okay. ax cubed minus 2ax squared plus 5ax minus 10a. So there's 4 terms, but be careful because this problem, there actually is a greatest common factor for all 4 terms, and that is a. So we'll take a out and we get x cubed minus 2x squared plus 5x minus 10. So we've taken out the greatest common factor, but now we're going to look at the 4 terms inside the parentheses, and we're going to attempt factoring by grouping on them. I'm going to switch over to brackets instead of parentheses, because I'm going to have parentheses inside my brackets here in a minute. So let's see, let's do this. Okay, so that, if I take the greatest common factor out of that, it would be what? X squared, and then I'd have an x minus 2 left over. And then over here, I'm going to take out a 5 and have x minus 2 left over. And I'm going to need a plus sign there to make it work. So now I've got a, this a from the outside, and then x minus 2 coming out, and then x squared plus 5. So that's my final answer. Any questions there? Okay, let's take a look at this one. RS plus SX minus RY minus SY. So looking at all 4 terms, I don't see a greatest common factor other than a 1. So I'm going to split it up into 2 groups of 2. The greatest common factor of the first 2 terms is S, and the leftovers are R plus X. Now, the greatest common factor of the last 2 terms, I could take out a Y, but I could also take out a negative Y because they're both negative. So my question is, do I want to take out a Y or a negative Y? Well, before we answer that, let's go back to, let's see. Let's go back to this one. Notice that these two matched. Because they matched, I could bring it out as the greatest common factor. Here, these two matched. Because they matched, I could take it out as the greatest common factor. Here, these two matched, etc., etc., etc. Okay, so now, what do I want? I want them to match. So I want this to be equal to that. So rather than trying to figure out what I'm going to take out, let's figure out what I need left over. I need r plus x. So that means I need to take out a negative y rather than a positive y. Does that make sense? Okay, so what I tell students is don't look up, look over here to figure out what you need there. So now I'm going to get an r plus x and an s minus y. Looks like a 5, but that's really supposed to be an s. Okay. Questions there? Good to go. All right. Let's see here. Let's take a look at this one. Y cubed minus 12 plus 3y minus 4y squared. Once again, we have 4 terms. I don't see a greatest common factor other than a 1, so I'm going to split it up into 2 groups of 2. Well, when I do that, looking at the first 2 terms, the greatest common factor is just like a 1, so I've got that. But here the greatest common factor is a y, so I've got that, and that's just not going to get me where I need to go. So what I'm going to do is I'm going to go back to the beginning, and I'm going to write this thing in descending powers of the variable. Okay. So let's see here if I can get this eraser to work. So I'm going to write y cubed minus 4y squared plus 3y minus 12. Do you follow what I mean by descending powers of the variable? Okay, good. So I've put it in standard form. Now I'll go back and see if I can group it. So if I need to rearrange the terms, I can do that. So now my greatest common factor here would be y squared, and I'd have a y minus 4. So what do you think is going to go over here in the parentheses? Well, it's probably going to be a y minus 4. And in fact, if I take out a positive 3, I get a match of y minus 4. So then I've got y minus 4 times y squared plus 3. And there you have it. Good to go on that?
Mr. Mayo?
Yes.
So for the question before that, how did you get the X?
This one here?
Yeah.
Okay. Oh, you know what? I think I copied something incorrectly or did something incorrectly. Let's see. Yes. Yes, I copied the problem incorrectly. Thank you. So let's do this one over. This is supposed to be an X right here. Okay. And so that's going to change things considerably. Yeah, I copied the problem wrong. Okay, thank you. So Rx plus Sx minus Ry minus Sy. Oh, I'm so embarrassed. Okay. Greatest common factor here is just a 1. If we split that up, we're going to take out what? An x. And we're going to have an r plus s left over. So over here, I want an r plus s left over. So I'm going to take out a minus y, which is going to give me an r plus s x minus y. Thank you. I'm glad that someone was awake this morning. Obviously, it's not me. Even with these wonderful dollar store glasses, I still didn't copy it right. Sorry about that. Any other comments before I go on? Anything else that I screwed up?
No, that was
Okay.
I was just
Yeah, no, I'm glad you did. I'm glad you did. I did not see it. Okay. So let's take a look at this problem. H squared 14 plus r plus 5 times 14 plus r. So here, it's already partially factored. The greatest common factor would be 14 plus r, and the leftovers would be h squared plus 5. And we're done. Any questions there? These problems that I'm doing are examples out of the regular textbook. If you happen to be one of those people that got the textbook and you want to know where I'm getting these problems, tell me and I'll say, oh, this is page 441, problem number 101. Otherwise, I won't bother. But if any of you want that, let me know. Okay. 22a cubed minus 33a squared. So 22 has a factor of a 2 and 11. 33 has a factor of a 3 and 11. So we could take out 11a squared, and left over would be 2a minus 3. I want to do this problem again, and I want to deliberately do it wrong just to show you how do you know whether you're doing it correctly, okay? So looking at 22a cubed minus 33a squared, I'm going to guess that the greatest common factor is 11a. If I do that, my leftovers are a squared minus 3a. But looking at my leftovers, I see that I could have taken out an a. So if that leftover still has something you can take out, then you didn't take out the greatest common factor. Start all over, go back and take out a bigger amount, okay? So you want to make sure that what's left over doesn't have a common factor other than a 1, because if it does, you should have taken it out. You want to take out the greatest common factor. Okay. Let's see here. AX plus BX minus A minus B. And I'm going to split it and see if we can do that by grouping. The greatest common factor of the first two terms is an X, leaving an A plus B. Now again, what's common to the last two terms? Well, just a 1 or a negative 1. Which one is it? Well, I want this to match with that. So I would take out a negative 1. Now, I've had students say, well, do you really need to put the 1 there, or can you just write that? You can just write that, but if you do, then in your next step, you might just put that. So I think it's better to put that 1 to remind us that we need the 1 down below, okay? I think of Hansel and Gretel. Do you know the story of Hansel and Gretel? They went out in the woods and they were afraid they'd get lost, so they left a trail of breadcrumbs. So the idea of leaving a trail was a good idea so that they could get back. But unfortunately, they used breadcrumbs. The birds ate them, and well, you know the rest of the story. It gets the witch and the candy house and all that stuff. But the point is, you need a trail to be able to get back to where you started. So be careful you don't ignore that 1 when you need it. All right. Let's see here. as we progress through this chapter, we're going to find that when we have an expression and the leading term is negative, typically it's going to be easier for us to deal with the rest of the problem if we factor out a -1. And here again, you could write it that way, or you could write it this way. It just depends. You know, in some contexts, that 1 is going to remind you to do things. Here, since this is the final answer, not as big a deal. Let's see here. 12 u v w cubed minus 54 u v squared w squared. So let's see here. 12 and 54. What goes into 12 and 54? Does 12 go into 54? No. How about 6? I think 6 goes into both. So we need a 6. We've got 1 u in both terms. We've got a v and a v squared, so we'll take the lowest power. We've got w cubed and w squared, so again, we'll take the lowest power. 6 times 2 is 12. uv, oh, I still need a w, don't I? To get back to w cubed. And then minus, let's see, 6 times what is 54? 6 times 9. And then, let's see, I've got a u, oh, I need a v. And that's it, in fact. So this parentheses is bigger than it needs to be over here. For 2 quarters, I've been trying to get this eraser to work for me all the time, and it's stubborn. So let's check our work. Let's see, that would be 12 u v w cubed minus 54 u v squared w squared. So it's correct. All righty. Let's see this one. -3r plus 2s minus 3. That's a strange looking s, but there isn't any, I can't really see anything to take out other than a 1. But our leading term is negative, so let's just take out a negative. 3r minus 2s plus 3. Think about this. When you distribute a negative, you take a negative times something, it changes the sign of everything inside. So when you factor out a negative, it also changes the sign of everything inside. This goes from negative to positive, positive to negative, negative to positive. All right. Well, I think I've tormented you enough for today. So we're going to call it quits. So let me go ahead and stop the recording.